So let's start. Number one. So the first step we're going to do on every problem is get the absolute value by itself. And that does not apply on problem one, and it does not apply on problem two. So once the absolute value is by itself, what we're going to do is we're going to go and I'm not going to mention those. I'm going to say it one time. I try not to say it again, splitters and squishers. We're just going to let the problem happen naturally, the way we should be. So we're going to start out by looking at this first off, and this is a big one, and this applies to several of you in this room. The first thing you need to check once you get the absolute value by itself is you need to look at this number over here. Why do I care? Because it's a positive and it matters. And if it's a negative, what would I do at this point? I would be done. I would not show any more work. And that's a memo that oddly enough didn't get through to some of us, is that we still go on and like set up the problem like it's a thing. And I'm so sorry that you missed that memo. If that had been a negative 16, this problem is over. Any work you do past this point is invalid. It's not right. It's not okay. It's not above and beyond. It's wrong. Okay, so as we go through this, and I'll say this again, if that had said negative 16, do not show work, do not write and, do not write or. You stop and you either choose, is it no solution or is it all real numbers? And since it doesn't apply, I'll talk about that when we get there. So what I'm going to do is I'm going to replace that greater than sign with an equal sign, and I'm going to write two equations. And one of them is going to say 8x equals 16, and the other one is going to say 8x equals negative 16. Okay. And now what we're doing here, remember, is we're not finding regions yet. We're not finding like answers. We're finding split boundary points. And so when I solve these two little baby equations, the red one, if I divide both sides by 8, gives me x equals 2. If I solve the purple one, it gives me x equals negative 2. So we're going in the way, way back machine here to where the first day we did this. This is how I taught it, and I should have left it alone. So we're going to make a number line now. And we're going to mark those two numbers on the number line. So we're going to put 2 where it correctly belongs. We're going to put negative 2 where it correctly belongs. And then we are going to put the correct circles. Because there is no or equal to in the original problem, I'm going to make marks, but I'm going to leave them open. We know this much going into this. Negative 2 and 2 are not solutions. Okay? So this is the way we're going to do this from now on. We are going to test numbers in all three regions. So can someone give me a number in the center?
0.
0 is the perfect choice for this particular instance because it's between negative 2 and 2. So I'll write down my test number here, 0. And what I'm wondering is, will it work? And what we're going to do is we're going to go back to the very original problem. And I say that because a lot of times what's happening is we're making mistakes when we get the absolute value by itself. And so I put a little bit too much faith. So like say the original problem had been like, had like negative 4 times the absolute value of 8x is less than negative 64. I put infinite faith in that every one of us in this room, if we divided by negative 4, would remember to change the sign. But that was an erroneous bit of assumption on my part, right? We're not perfect. And so if you test the point 0 that Kane said, if you test 0 here, but you forgot to change this sign, then you're getting invalid results. So what we're going to do is we're going to go back to the very original problem, the one that's typed on the paper, and that's where we're going to test our points. Okay. So that if we made a mistake, like forgetting to change a sign, it's not going to crush us because we're not using a broken tool to do a job. So having said that, this is all invalid in this case because the absolute value, you can't mess it up because it was already by itself. So it said is greater than. So let's test it. If we put 0 right there, do the math. What's 8 times 0? And what is the absolute value of 0? It is 0. And is 0 greater than 16? So here's what I can tell you, and I can say this now. This is going to save us some time, is that every graph on this quiz is either going to be one of these or one of these, because I took the variable ones off. And so every quiz on this graph will either be red or yellow. If 0 didn't work, what does that mean? That it's, no, 0 didn't work. The red one doesn't work. If you can prove, which we just did by testing the number 0, that the red did not work, then this solution region does not work. So if I'm here telling you that it is either going to be the stuff in between or the stuff outside, there is no middle ground. Which one does it have to be? It has to be the outside one, and the problem is now over. If you want to test every region just to be thorough, you can. But I feel like if we tested 0 and it failed, then logic kicks in, and I'm like, well, hell, it has to be the 2 on the outside. But just to make sure, let's test regions just to validate our assumption. What's a number that's to the left of -2? So let's test -3. And again, to do that, we're going to go back to the original problem up there at the top, and we're going to put -3 where that arrow is pointing. What's 8 times -3? -24. And what is the absolute value of -24? Is 24 greater than 16? Yes, and that validates that this yellow shading is legit. And again, just to, if you want to do your full due diligence, if you're on a mission, say, I'm going to get 100% on Monday, just to make sure, let's test a point that's in the other yellow side. What's to the right of 2? +3. Same thing. Put 3 up there at the top where the yellow arrow is. What's 8 times 3? 24. And what's the absolute value of 24? And 24 is also greater than 16. So that validates for us that the yellow graph is the correct answer. Now, we're not quite out of the woods yet. We have to actually write the answer. Okay. And this, yes, remember the ands and the ors are really critical here. I should never see the word and in your final answer for the record, because we should be writing those a different way. But when it splits like this and goes outwards, we write this answer as an or. It has to be an or. So we're going to say that x can be less than -2 or x can be greater than +2. And we're done. This method is almost fail-proof. I mean, we're going to have human errors, like saying silly things like 8 times 3 is 16. And we are human and we do things like this. But overall, if we're solid on our little things, you cannot miss these problems this way. Let's go to problem number 2. So again, the whole absolute value getting it by itself thing doesn't even apply to this because it's already by itself. So we're going to take the inequality sign and we're going to change it into an equals sign, and we're going to do -9 plus p equals regular 18. And on the other side, we're going to do -9 plus p equals the other 18, called -18. And I, of course, teach this today with the assumption that you're not going to mess this up. You're going to know to add 9 on the red equation. What do you get? You're going to get 27. And on the purple equation, you're going to add 9 and get p equals what? Good. We don't have answers yet. Understand that all we have found are the split points, the points, the 2 numbers on the number line that will break this number line up into 3 pieces. So -9 goes here. +27 obviously goes here. And I'm going to put circles, and I'm going to, again, leave them open because there is no or equal to. And what I'm going to do now is, again, I'm going into this. God, I hope you're listening. I'm going into this knowing that it's either going to go like this clear or like this. I'm not mincing words here. I'm not speaking in code. It will be one of those 2 situations. Clear? So let's test. My logic is this. Should I ever have to test all 3 regions? Not on this quiz. The next quiz, that'll come back and play. But for now, if I test 1, knowing how the graph has to look, that should be all I need to test. So let's test a point again in the middle. And the easiest number in the world is available to us. What's a good middle number? 0. If 0 is in play, I'm going to pick that guy 100% of the time. 0 is the best friend in math. Easiest number in the world. So let's go back up to the original problem and let's test 0 because he's right there in that middle spot. And if he works, I'm done. If he doesn't work, I'm done. So I'm going to put 0 right there where the yellow arrow is pointing. And again, no math errors. What's -9 plus 0? What's the absolute value of -9? Is 9 less than 18? Yes. So because that gets a green check mark, I know now that the answer to this problem will be shading in here and not on the outside. So far, so good. So the graph is done. Now what I'm going to do is I'm going to write the solution. And I do not want you using the word and for these particular types of graphs, okay? So what we're going to use instead is the compound inequality notation that basically says, okay, -9, you're my left boundary, 27, you're my right boundary, and x, you're in the middle. Just like this. You only have to write one answer because it counts for 2. And to get you through this, remember that your Pac-Mans on these will always waka waka to the east. PX, I'm sorry, P, my bad. Let me fix that. No, that's my bad. That's my bad. That's it. That's your answer. That's how you write the squishy in the middle kind right there. Simple, pimple. Everything in this white box, problem over, done. That's how simple it is. Okay, that making sense? Now, when we get to problem 3, things change. And again, we're human. We do funny things, we humans. I wish we were all just perfect, but no. I mean, no. So what's our job? What's our primary job? Get that absolute value brick by itself. Specifically in this case, what does that mean to do? We're going to add 2 to both sides. And when we do that, we're going to reach the promised land where we make splits. So we're going to go absolute value of 5x is less than 43 plus 2, which is 45. And I'm not going to tinker with this whole and or thing with you. I'm not going there. Lesson learned. I know now. I'm going to write 2 equations. One of them is going to say 5x equals the number that I see. The other one is going to say 5x equals the other version of the number that I see. And I'm going to solve these to find my split points. What's the solution to the red equation? What's the solution to the purple equation? And there is no and right now, and there is no or. It's not even a topic that's in my mind. My question right now is, where am I going to shade on the number line I'm about to draw? And again, you should only ever have to test one region, because if you know the graph's going to look one of 2 ways, one's enough. So now I'm going to make a number line, and I'm going to mark my boundaries, and I'm going to test me a point. So I'm going to put my boundaries, again, correctly where they belong. Occasionally, people put numbers in the wrong place, which, you can't do that. That's not allowed. And then I'm going to test. Where do you guys want to test? I would test in the middle because 0's in there. It's my guy. So if I go and I test 0 right in here, remember, we are not going to test here. Why not? Because it's not the original problem. And being human, there's a chance that we did something hilariously dumb, like subtracted 2 from both sides. And so that's not guaranteed to be a perfect product. This original untainted problem is where we need to be testing our numbers, because we didn't do anything to it. It's guaranteed to be just perfect. The OG problem. So now we're going to head up there where the little yellow arrow is pointing, and we're going to put in our favorite number, 0. 0 will almost always be available to you, FYI. One of your boundaries is on 0, then you're like, I got to go elsewhere, but 0's our guy. So if I put 0 in there, what is 5 times 0? What's the absolute value of 0? And what is -2 plus 0? It is -2. Is -2 less than 43? Then the point 0 is a win. And if this point is a win, then every point in his region is a win. which by default on this quiz means that these will be fails. Without the variable on the other side, we're not going to get any of those weird ones where there's like, two overlapping regions. It's not going to happen to us, right? So I got to get my circles put in. There was no or equal to in this problem. So I'm going to go ahead and get my boundaries placed again. And I am going to place my shading right where it belongs, where the green check mark tells me to. And my graph is done. How do I write this solution? Just like that. Pay attention as I see all of you writing really, really a lot today. And I see that you're learning and I see some noddings of heads. Pay attention to one critical detail. Please note again that those inequality signs are both less than. That's how we create a flowing statement from left to right, as we say, this guy's less than all this crap is less than this guy. They're both less than. Done. Problem 4. Sorry, Mari. What do we have to do? No, we have to divide. Don't add it. Don't subtract it. This particular -8 is a stick-on multiplier. And I will say, if you added 8, you're not the first and you won't be the last. But remember, if I wanted it to be a separate added away guy, I would have stuck a plus in between it and the absolute value. It's an attacher. You kill it by dividing. So we divide by -8 and we divide by -8. And we are left with uh, the important sort of split point. So we're going to say we do have to switch our sign. And using this new method, the good news is, and this is what I was saying earlier, is that if you forget to switch your sign, you can still get this problem right because you're not going to use it. Like, let's just say that, like a knucklehead, I forgot to change it and I leave it as a less than. This is never going to come back to haunt me because I'm not going to test points in here anyways, right? So I'm going to change it because I don't want anything defective on my recording. But there. Now we're going to write our two equations based off of that product. And one of them is going to be p plus 4 equals the number that I see. And the other one is going to be p plus 4 equals the negative version of the number that I see. On the red equation, if I subtract 4, what do I get? Perfect. Boundary found. On the purple one, if I subtract 4, what do I get? Boundaries found. This is the part where I now draw the number line and I go on the hunt for who do I shade. And just the nature of these is that the numbers don't look like they're in the right order. That's just on you to not be a knucklehead. Put the numbers in the right spot. -14 obviously goes to the left of +6. There is no equal sign in this problem, so I am going to leave my boundaries hollow, and now it's time to test. And for the 4th straight time, who's available? Let's use him. Take 0. He's our bestest friend. But remember, do not test him here. There is a chance that that's no good. We're going back to the original problem before we screwed around with it, and we're going to put 0 right there. What is 0 plus 4? What's the absolute value of 4? What is -8 times 4? -32. Is -32 less than -80? Not in a million years. -32 may feel like a smaller number, but because they're negatives, the smaller one is actually the bigger one. So this is a lie. -32 is not less than -80. So because it's false, the center region gets the X. Do I have to test numbers on the outside? No, because if I know dang well that the graph's going to look one of two ways, then by default, I know those are both going to work. And again, I'm not going to, but if you wanted to, just make sure Time's not going to be an issue. This is not a 45-minute test if you know what you're doing. If you want to do it, test a point. Go ahead, test -15. It'll work. Go ahead, test 7. It'll work. And it'll just validate that that's where the shadings should go. So the graph of this is going to look like this. The shadings are going to be on the outside. And the question now is, how do I write the answer? So let's write the answer. What do we write? You cannot shortcut this. There is no short way. You just literally write this one, and stick the O word in the middle, or that's it. So how do we write the left one? P is less than -14. That's a representation of the green arrow on the left. How do we do the right one? And then we stick this word in the middle and we put a big old proud box around this and we're done.
Yeah.
6. I don't know. I wrote 7 because I saw a big green 7. See, and I'm proving the point here today that humans are indeed capable of doing awesome things. Sarcasm, mistakes. Got it? On to the back. Next question. Again, the absolute value is not yet by itself. I am going to bypass a step. So just because, you have the test in front of you. So it's the absolute value of 1 plus 3x. I am going to go ahead and subtract 2 from both sides, which is going to give me -25. I'm not ready to make any choices yet. I'm not ready because why? Because it's not by itself, but I can make it by itself if I get rid of that clinger. How do we kill a clinger? We divide, right? You don't subtract or anything here. You divide. And if you divide both sides by 5, you do not change your inequality sign because you didn't divide by -5. So we get the absolute value of 1 plus 3x is still greater than what? This is where you stop. I don't know where I failed in explaining this. Do not treat this now like a math problem. Do not write 2 equations. Do not look for boundaries. I assure you that this problem will be one of 2 things. It will either be all real numbers or it will be nothing, no solution. We clear? So let me ask you this. When it comes to the absolute value, will the absolute value always or never produce an answer bigger than -5? What will this yellow machine always give me? A positive, or at the very worst least, 0. So will its answer always or never be bigger than -5? Always. So the answer is all real numbers. You do not write equations. You do not try to find boundaries that have no meaning. You're done. And now what you need to do is make a graph. As annoying and silly as it might seem, the graph still has to exist. And the graph is a number line. So there should be a physical number line there. And then over the top of that number line, there should be visible shading with arrows on both ends to indicate that my solution set goes infinitely in both directions. Done. Put that in your notes. I assume some of you are going to remake a page of notes. I assume you're working on it now. And put that in there. That stop, pause, pump the brakes. When you get that absolute value by itself, that's a real critical moment to just stop and take a look. If it's negative, pump the brakes. Problem's over. You just got to figure out which of the 2 things it is. Okay? Question 6. To get the absolute value by itself, we still have a clinger. We have -6 times the absolute value of 5 plus 10k. I am going to subtract the 7 over to the other side. And again, you're just not allowed to mess up subtraction and addition, right? So -23 minus 7 more makes -30. What do? We do. And this also goes in our notes. And I think the vast majority of us, this is not an issue. Like this memo, I think we mostly got that when we divide by that red negative number, that Pac-Man is going to change. He's going to have to turn around. So what used to say greater than or equal to is now going to say less than or equal to. Okay. And then what is negative 30 divided by negative 6? So I pump the brakes a little bit. I stop. I look at the number 5 and I get the green light because 5's not negative. I'm heading in. So I'm going to now construct two equations. One of them is going to say 5 plus 10k equals exactly what I see. The other one is going to say 5 plus 10k equals the opposite of what I see. And I'm going to solve. We solve the red equation, we have to subtract 5 first. We get 10k equals 5 minus 5 is 0. Sometimes there's a few of us around who think that this is something significant, like it means no solution. Quit picking on 0 like he's like a bad guy. Dude, if you divide 0 by 10, there's nothing no solution-y about this. It's just 0. It's a number. Yeah, you guys hurt 0's feelings when you act like he's some kind of pariah. On the purple equation, if I subtract 5, I get 10k equals what? Correct. Then if I divide both sides by 10, I get k equals negative. Anything divided by itself is 1. So negative 1. So now I'm going to draw my number line and I'm going to determine my regions. And my regions will exist. Here's negative 1. There's 0. And my boundaries are going to be colored in. This was actually the only one on this quiz, I believe. I went back and looked and I was like, wow, that's the only one. I probably should have paid attention. There. Great. Can't test 0, right? 0 would be useless. So who do you want to test? 1's fine. So I would put, when I put my test number down, I would put it where it belongs. 1 is here. So we're testing the region on the right. If it works, we're done. If it doesn't work, we're done. We will know everything we need to know because the graph will look one of two ways. If we do not test 1 in our modified problem, we go back and test 1 all the way at the very beginning, which I should have probably put it on the board. In hindsight, I kind of now wish I had, which is negative 6 times the absolute value of 5 plus 10k plus 7 is at least negative 23. If this works, doesn't work, we have all the information we need. Now we're testing the number 1, and we're going to put 1 right where that yellow arrow up there is pointing. What's 10 times 1? What is 5 plus 10? What is the absolute value of 15? So we have negative 6 times 15 plus 7. And we're just waiting now to see what that comes out to be. We want to know, will it be bigger than or equal to negative 23? That's all I want to know. What's negative 6 times 15? It is negative 90. And what is negative 90 plus 7? Negative 83. Is negative 83 greater than or equal to negative 23? Not in a million years. It's super way less than. It's 60 units to the flipping left, right? This is false. And if it's false, then the point that we tested doesn't work. So the point we tested is false, which means that's false, which means by default that's false, which means by default that our graph exists in here. How do we write it?
Less than or equal to.
Done. Questions? Okay, we have 2 more to do. On question 7, I am going to just copy the original problem this time because I don't know. I should have been doing that from the beginning. What do we do first? No. 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 Of course you do. This is listen, I need to know if I put this equation as the guy that was your algebra teacher, If I gave you this equation, I can't sleep at night if I think you're not going to add 10 to both sides. You need to know that mechanically that goes first. Getting rid of the straggler term is step one. And to get rid of a negative 10 that's detached, you add 10. And if you add 10 here and here, you get negative 10 times the absolute value of 3 minus 5x is still greater than 70. Now, what do? Now we divide both sides by negative 10. And I get the absolute value by itself. Mission accomplished. And I am going to remember to switch the sign because I divided the red numbers a negative. So I'm going to switch it to is less than. And what is 70 divided by negative 10? What do we do from here? Stop. The problem is over. Do not write equations. Because the 7 is a negative, you're in one of two categories now. It's either always going to be true or it's never going to be true. How often will this yellow machine give me an answer that is less than negative 7? Never. Because the lowest it's ever going to give me in a trillion years is 0. He's like, I'm sorry, I'm not capable of producing anything less than negative 7. I can't do that. For that reason, the answer to this problem is that there is no solution. The equation, the inequality, excuse me, cannot be solved. Impossible. And now we need a blank, bare naked number line to finish the deal. So for a problem like this number line is it. No numbers on it, no nothing. It's just a buck naked number line showing me that, hey, I got nothing. Last one, okay. Number 8 is 2 times the absolute value of 5 minus 2p plus 4 is greater than 54. I am going to subtract 4. And then I am going to divide by 2. And I have now reached the promised land. We made it. We do not stop because 25 says, keep going. I'm positive. There's some meat on this bone. So we're going to write 2 equations based off of this. One of them is going to say 5 minus 2p equals that dude. The other one is going to say 5 minus 2p equals the other dude. How do I solve the red one? Love it. Purple one. Solid. No switching signs, no worrying about and, no worrying about or. I'm just finding my split points. So now I'm going to draw my number line. And on my number line, I'm going to mark my split points. Put them in the correct place. So negative 10, positive 15. This is another one, the 7th one that has no equal sign. So I am going to mark these as open. Okay. Again, who's our guy? Zero's my guy. Use him. Best number in the world. Makes math so easy when it's option, and it's almost always an option. So I'm going to go back to the very beginning, and I'm going to put 0 right there. Here we go. What's 2 times 0? 0. What's 5 minus 0? 5. And what's 2 times 5? What's 10 plus 4? Is 14 greater than 54? It is not. Therefore, the point lies in a bunk region, which means by default that these regions will work. And I will say for the 3rd time today, if you're not comfortable with that, then do your thing. take -11 since it's in that region, test it just to validate that it works, and then take 16 and validate that it works. It will. Because on this quiz, your graphs are either going to be inside-y guys or outside-y guys. So now we need to write our answer. The graph is done. Done. Good. If you got a super good score, you do not need to be a part of the retake on Monday. I mean, if you want to improve your 63 out of 64 to a 64 out of 64, you're welcome. But if you got one of the 3 or 4 pretty stellar scores, you're welcome just to bring something else to work on Monday. But everyone else, you're doing this again. It'll be a different test, obviously, but nothing will change concept-wise. If you don't feel still like that's something you're good with, come in for flex, come in for lunch, stay with me after school, come into 8th hour because I'm doing it all again. Okay? Cool.